Good morning to all of you. Today we will discuss mechanics of solid or strength of material. Mechanics of solid. Right? Now, the topic is simply supported beam carrying UDL. Shear force bending moment diagram. And the topic is simply supported beam carrying UDL. Carrying UDL. Right? Simple supported beam carrying UDL. First, draw the simple supported beam. This is simple supported beam AB. This is RARB. A, B, RA, RB. This is UDL. Double for unit length. Meter length. Length L. Length is L. Now, so total load is double L. Double L. This is L by 2. This is L by 2. Clear? The total load is double L and is acting center of the beam. This is point C. This point is C. L by 2. L by 2. Right? Consider a simply supported beam. Simply supported beam carrying UDL. Carrying a UDL uniformly distributed load of double per meter length. Over the entire beam. Over the entire beam. Clear? The total load is double L is acting at the center of the beam. Let RA is equal to reaction at A, RB is equal to reaction at B. At A, B. Clear? Now, sigma y 0. First find out what is reaction at A and what is reaction at B. What is RA and RB, what is RB. First we will find out what is RA and what is RB. Now, sigma y 0. RA plus RB is equal to double L. Question 1. RA plus RB is equal to double L. Clear? Take moment out A. Taking moment about A. About A. Right? So RB into L is equal to RB into L is equal to double L into L by 2. Clear? RB into L is equal to double L into L by 2. Now, LL cancel out. What is RB is equal to? L by 2. RA. From equation 1, RA plus RB double L. What is RA is equal to? Double L minus RB. So double L minus double L 2. Double L 2. This is RA is equal to. Clear? This is RA double by 2. This RB double by 2. Since this is symmetrical loading, the load is distributed uniformly over the entire beam. So RA is equal to RB is equal to double by 2. That means R and RB are both are equal. Now first make shear force calculation. Shear force calculation. This is double L by 2. This is double L 2. A, C, B. Clear? So shear force at B just right. Shear force at B just right 0. At B, the reaction double L 2. This will count for shear force at left. Shear force at left at B just left. Minus double L by 2. Right? Now at point C, shear force at C is equal to minus double L by 2 plus from C to B double L by 2 0 is equal to 0. Now from C to A, the load is double L by 2. That will count for shear force at A right. Shear force at A just right plus double L by 2. At A left 0. Shear force at A just left double L 2 and double L 2 0. Clear? Again I am explaining. Shear force at B just right 0. At B left minus double L 2. From B to C, the load is double L 2. That will calculate for C. So shear force C is equal to minus double L 2 plus double L 2 0. At A right, from C to A, the load is double L by 2. That will count for shear force at A right. That is A right double L 2. A left double L 2 minus double L 2 0. Right? Now draw the SF diagram. Scale 1 semi is equal to double L 2. Clear? Now at B just right 0. 0. B just left, minus double by 2. C 0, 0. A just right, double by 2. A just left, 0, 0. Right? Start from B left, B right, 0, 12 by 2. C 0, double by 2, 0. Plus, minus. So, at point C, the shear force changes sign from positive to negative or from negative to positive. So, this point, the bending moment is maximum. At point C, the bending moment maximum, I will calculate what is the maximum value of bending moment at point C. Right? Now, this is SF diagram. SF diagram. Now, BM calculation. Bending moment calculation. Bending moment at B 0, because right to B there is no force. So BM at B, at A 0, at A also 0, because I have already told you design points. In case of simple supported beam, at two supports, the bending moment is 0. Now find out the bending moment C. Let's see. See here, this is double L by 2. This is L by 4. Clear? Double L by 2, L by 4. So what is this answer? So MC is equal to double L by 2 into L by 4. Double L square by 8. Double L square by 8. Hence, at point C, the bending moment is maximum. The bending moment is maximum and is equal to double square 8, where the shear force changes sign. The shear force changes its sign. Changes its sign. Clear? 8.C, the shear force changes sign. Hence, at this point, the bending moment is maximum. It is equal to double L square 8. Second degree of L. So this curve will be parabolic. Parabolic curve. This is A, C, B. Suppose this is double L square 8. Here A is 0. At B also 0. BM at B0 is 0. At C double L square 8. The curve is parabolic. This is all positive. So the diagram is above the baseline. Above the baseline. This is parabolic. This is parabolic. Clear? I will do some problems related to this theory. This is question number 56. Last class I have already done 55 number of problems. This is 56 question number. This is B may be. B may be. The beam is 6 meter long, carries util of 2 Newton per meter length in a length of 3 meter from the right support B. Draw the SFBM diagram for the beam and find the maximum value of bending moment. Here, we will draw the figure. First, we will find the reaction at A, reaction at B. This is RA, RB, RA and RB. Let RA is equal to reaction at A. Let RA is equal to reaction at A. Let RB at B. At A. Clear? At A and at B. Now, sigma y0. This is 2 to 3, 6 Newton. This is 1.5 meter, 1.5 meter. Clear? The total load is 2 into 3, 6 Newton is acting at half to the length BC, point C. Clear? Now, RA plus RB is 6. RA plus 6 equals 1. About A. Taking moment of A. Taking moment about A. That is sigma m is equal to 0. go day. Now RB into 6 is equal to RB into 6 is equal to 6 into this length. This is 3. Clear? 6 into 3 plus 1.5, 4. 4.5. What is RB is equal to? 4.5 kilonewton per Newton. RB. From question 1, what is RA is equal to? 6 minus RB. So 6 minus 4.5 is equal to 1.5 Newton. RA. Clear? This RB, RA. What is RB is equal to? RB is equal to RA is equal to 1.5 Newton. RB is equal to 4.5 Newton. Right? Now make calculation for shear force. Then we will draw shear force diagram. Then calculation for bending moment. Then we will draw bending moment diagram. In bending moment diagram, we will find out the point where the shear force changes its sign. At that point, the bending moment is maximum. Clear? We will find out the maximum value of bending moment. Now, bending moment at a B just right 0. Clear? At A, the BM is, the shear force is, but BM, sorry, shear force calculation. Shear force at A, B just right 0. Clear? The B, the reaction is 4.5. That will calculate for left. Shear force at B just left minus 4.5 Newton. Right? Then let's see. Shear force at a C. Let's see. Minus 4.5 plus 6 plus 6 1.5 Newton. Clear? A just right. Shear force at A just right 1.5 Newton. A just left to 0. Shear force at A just left 1.5 minus 1.5 0. Clear? I will draw the SF diagram. A, C, B. At B, just write 0. Now B just at 0. B just left minus 4.5. Minus 4.5. C just C 1.5. 1.5. A just right 1.5. 1.5. A just left 0. 0. Clear? Now draw this SHEAR diagram. 0, 4.5, 1.5, 1.5, 0. This point M. At M, the shear force changes sign from negative to positive or positive to negative. So at this point, the bending moment is maximum. Right? This is positive, this is plus, this is plus, this is minus. Clear? Suppose the distance x, what is this? 3 minus x. Right? Now, this is shear force diagram. We will calculate bending moment. So first calculate what is F, S, X, BM calculation. Right? The shear force changes at point M. The shear force changes its sign at M. At M. Clear? Where the bending moment is maximum. Now, find the point C. Let this point is x distance from C. 3 months x distance from B. Let the point M is x distance from C. From figure, this from figure, this is right angle triangle, this is right angle triangle. Clear? So compare these two triangles. From mathematics, we know x by this is equal to 3 minus x by this. Clear? So from figure, x by 1.5 is equal to 3 minus x by 4.5. Now 4.5x make cross multiplication is equal to 1.5 into 3 minus x. So make calculation for x. Clear? We will find x is equal to, make calculation for x, we will find x is equal to 0.75 meter. 0.75 meter. So this is 0.75 meter. This is 0.75 meter. So what is this? 2.25 meter. 3 minus x. Clear? So this is M point. M. This is x. This is 3 minus x. Right, x is 3 minus x. Now first find out the bending moment at point B. Now at B the bending moment is 0. At B, BM is 0. Clear? At M, BM is equal to, at M means up to this. So RB into this plus 2 into 3 minus x into 3 minus x by 2. This is 2 into 3 minus x. And this is 3 minus x by 2. Right? So at B is equal to, at M is equal to BM at M. RB into 3 minus x minus 2 into 3 minus x into 3 minus x by 2. This answer. Right? 2 to cancel out. So what is RB? 4.5. So bending moment M is equal to 4.5 into 3 minus x minus 3 minus x into 3 minus x. Put value of x is equal to 0.75. Put x is equal to 0.75. Put x 0.75. Clear? So BM at M is equal to, put value of x is equal to 0.75. Bend node M is equal to 5.06. Clear? 5.06 Newton meter. 5 point at M. Then at C, BM at C, RA into 3. RA into 3. What is RA? 1.5 into 3. 4.5 Newton meter. At A, BM at A, 0. Right? At A, 0. At C is all this. What is this value? 1.5 into 3 means 4.5 Newton meter. At A, BM is equal to 0. Right? Now, draw diagram. All are positive. So all value drawn above the baseline. A, B, C, M. Clear? A, B, C, M. At B 0, B 0. at M 5.06 Newton meter positive. Suppose this is 5.06 Newton meter. Clear? At C 4.5 Newton meter. This is 4.5 Newton meter. At A 0, this is 0. Clear? So join all the points. This is from A to C, straight line, because this is point load. This is straight line. From B to C, C to B, parabolic curve. Right. So this is straight line. This is parabolic. Clear? So all are positive. So the figure is above the baseline. This is plus. BM diagram. BM diagram. Clear? SHEAR diagram, BM diagram. This is positive, negative. So in the BM diagram all are positive. So this is how the figure is above the baseline. Next question, 57. This is question number 57. 57. Right? This is a simple structural beam carries udal of 3 Newton per meter for length of 5 meter from the left support A. Draw the shear force bending moment diagram for the beam and calculate the maximum value of bending moment. Clear? The question is a simply supported beam AB of 80 meter long, 80 meter long, carries a udal of 3 Newton per meter over a length of 5 meter from the left support. Left support. Here, draw the shear force and bending moment diagram for the beam. and find the maximum value of bending moment. The maximum value of bending moment. Clear? The question is, the simple shoulder beam AB, 8 meter long, carries a UDL of 3 Newton per meter for length of 5 meter from the left support. Draw the SABM diagram and find the maximum value of bending moment. Now, this reaction RA, this reaction RB, this reaction RB. Clear? First find out what is RA and what is RB. Let RA is equal to reaction at A, RB is equal to reaction at B, at A, B. First make sigma y0, sigma y0. So upward force, downward force, RA plus RB is equal to 3 into 5, 50 Newton. Clear? Take a moment of day. This is 3 into 5, 50 Newton. This is 2.5. This is 2.5. Right? Now, take a moment of day. Sigma is equal to 0. Take a moment of day. What is RB into 8? RB into 8 is equal to 15 into 2.5. What is RB? Clear? So now RB is equal to 4.68 Newton. 4.68 Newton. RA. What is RA is equal to? 15 minus 4.68. 10.32 Newton. This is RA. Use calculator for calculating the answers. 4.66 minus 10.32 is equal to 15 Newton. From equation 1, this is equation 1. Right? This RA is equal to 10.32 Newton and RB is equal to 4. Now, shear force calculation. Shear force calculation. Now, B just write 0. Shear force at B just write 0. Clear? This is B point. This is B point. So just try to B, there is no force. So at B, the reaction is 4.68. So that will calculate for left part. Shear force at B, shear force at B just left minus 4.68 Newton. Clear? Now at C. At C, there is no force between B and C. So this is continue from B to C. Shear force at C minus 4.68 Newton. Then at A, shear force at A just right minus 4.68 plus 3 into 5, 15. So this is equal to 10.32 Newton. A left shear force at A just left (10.32) minus 10.32, 0 equal to 0. Now draw the figure, take scale, 1 sub is equal to 4.68 Newton. Clear? A, C, B, A, C, B. At B just write 0. Scale 1 semi is equal to 4.68 Newton. Take scale. B write 0. Clear? This is B write 0. Right? B left minus 4.68. This is left minus 4.68 Newton. Next, at C minus 4.68. Continue from B to C. 4.68 Newton. A right 10.32. 10.32. A left 0. 0. Clear? So B2 0 to 0 to 4.68, then 4.68, then up to 10.32, then this is equal to 0. This is point M. At point M, this therefore changes its sign from positive to negative. This is plus, this is minus. Clear? So at this point, the bend moment is maximum. So first find out where the point M lies. Clear? This is M point. At point M, the shear force changes sign from negative to positive or positive to negative. So at this point, the BM is maximum. First find out the point B, M. Where the point M? Suppose this distance x. This distance x. What is this? I minus x. I minus x. Clear? BM calculation. BM calculation. Clear? The shear force changes its sign at M. At M. So at this point, the BM is maximum. So at this point, bending moment is maximum. Let this point z reduced x from left support. Let M is at x from A. From A. First find what is x. From figure, x by this is equal to 5 minus x by this. Clear? So from figure, from figure, x by this, x by 10.32 is equal to 5 minus x by this amount. What is this? 4.68. So solving, we will find out x. Value of x is equal to, you will use calculator. Okay. Value of x is equal to 3.44 meter. 3.44 meter. 3.44 meter is x. The value is 3 point. So what is this value? 5 minus 3.44 means 1.56. 1.56 meter. Clear? Now calculate the bending moment. BM calculation. BM at B. Bending moment at B. 0. Right? At C. BM at C. RB into 3. RB into 3. What is RB? 4.68 into 3. This MC. What is bend C? MC. MC is equal to, you will get answer. MC is equal to 14.8. 14 Newton meter. 14 point MC at M. This point M. The distance is 3.44 meter. This is X. What is X is equal to 3.42 meter. Now this is 2 Newton per meter, 3 Newton per meter. Clear? Find out what is distance, what is bending moment M. This is point M. M. Clear? At M, start from left, from A. BM at M, start from A. RA into this. What is this? X. RA into X minus this amount. What is this? 3 Newton per meter into X. 3x. This. What is this? X by 2. Clear? This is 3x Newton. Distance is x at 2 meter. So what is moment? 3x into x by 2. Array, what is array? 10.32 into x. 3.44 minus 3 into 3.44 square by 2. Clear? The answer bending moment M. The answer is 7.75 Newton meter. 70.75 Newton meter. Clear? This is maximum out of 2. This is maximum. Next at A. BM at A 0. Clear? Now draw the figure. All are positive, all are above the baseline. A, this M, this is point C, B. Clear? Now take scale 1 to 10. Scale 1 cm is equal to 10 Newton meter. 10 Newton meter. Right? Now at B 0, P 0. At C 14.04 Newton meter. This is 14.04 Newton meter. At M 7.75 Newton meter. M point 7.75 Newton meter. At A 0. Clear? Now from A to C, parabolic, this is udel, second power of x, second degree of x. C to B, straight line, first degree of x. So the diagram is like this. Clear? Right? This is straight line. Straight line. This is parabolic curve. Parabolic curve. All are positive. So all are done. They are both baseline. Right? Now, this is problem number 57. Just as I will do problems related to this chapter. Please make, like, share, subscribe to our channel. Thank you.